Bismillahirrahmanirrahim. So today we will finish chapter 4 of Holton Davis, which basically is on posted prices. This part is about how these apply to topics in industrial organization. So industrial organization is usually a whole course. It deals with basically the theory of non-perfect competition. Yani what happens when you have a number of different firms? Some can be large, some can be small. So generally you have oligopoly type structure. So what happens in such markets? So there is a huge amount of theoretical questions which arise because of the failure of perfect competition. So the main point to make here is that originally there was a lot of confusion about how to handle this. You are familiar with Nash equilibrium and Stackelberg leader follower and many other game theory concepts. It was thought that game theory will provide a solution, but game theory has completely failed to provide any solution to this problem. So there is no and what will happen in the industry, nobody knows. So now experimental game theory does offer some solutions, and some of these we will look at. So there are some very standard questions in industrial organization, and we will look at 3 of these questions today. So we start with section 4.3, which is a review of the results about posted prices and how this compares with competitive equilibrium. So there are 3 designs, which are 3 experimental designs which we look at in this section. One is the box supply and demand. This means supply is flat at a low cost, demand is flat at a high cost. If the demand and supply are unequal, yani one is larger, then whichever is the short side, they will prevail, they will dominate. So if there is excess demand, then the suppliers will be able to be able to capture all of the surplus. If there is excess supply, then the demanders will be able to capture all of the surplus. So there will be a huge amount of inequity in the outcome. Either one side or the other side will get all of the surplus. So this is what the competitive equilibrium theory predicts. What will really happen in such markets? This is what experiments reveal. So this is a question of industrial structure, in the sense that if you have an industry in which there is excess demand, and yani structure means that it's fixed for a while and there's no quick entry or exit. So then what will happen in such a situation? Competitive equilibrium theory makes a prediction. Is this prediction really true? That's what we will check in experiments. The second is similar to the first, in the sense that suppose you have box supply and demand but they are in exact equality. So then any price between the lower bound and the upper bound is an equilibrium. So who will get the surplus? Yani in this case we don't know what will happen, because there is no competitive equilibrium prediction. Any of the values between the supply cost and the demand value can emerge as the equilibrium. Now it turns out that if you look at posted prices, then because the sellers get to move first and the demanders cannot really negotiate, so if you have a 1 period game with posted prices, then there is a unique Nash equilibrium in which sellers capture most of the surplus. But what happens in a multiple periods, we don't know. And now the third design is one in which you have shifts in the demand to see if the posted prices can follow these shifts. And they can, because in standard oral double auction, you can you have revelation of demand and revelation of supply. So both types of knowledge are there. But in posted prices, there is much less information available, especially about the demand. So will changes in demand be picked up by the sellers, and will they respond? This is a question we don't know. So here is the first experiment. This has a box type supply and demand. In the first 5 periods, you have excess demand and short supply. So the equilibrium price is at $6.80, the upper flat line, and you can see that basically there are 11 units which are offered for sale at $5.70, and there are 16 units which are demanded at the value of $6.80. So both the demand and the supply are the flat, but there is 5 units of excess demand. So we've already studied this, so we are going over a review of this. So initially, because there is no knowledge in the market of whether there is excess demand or supply, prices start out right in the middle. If you look at the first period, all of the dots are in the middle. There are 7 sales. 4 sales do not occur. There should have been 11 sales, but for some reason the sales do not occur. But in the second period, things are stabilized. There are 11 sales and the prices are rising as people are discovering that there is larger demand, and they keep rising until about the 5th period they are nearly at the competitive equilibrium. Then in the 6th period, the demanders become 11 and the suppliers become 16. So now we have excess supply. So the competitive equilibrium is now $5.70, the lower line, and you can see that the price has declined slowly towards that. This is the this is the oral double auction, yes. This is the oral double auction situation, yes. So now what happens if with the same experiment with posted prices? So this is the posted price situation. It's rather different, as you can see. Here you have 10 periods with excess demand and then 10 periods with excess supply. So you see in the first 10 periods, you do have convergence to the competitive equilibrium. In the last period, in the 10th period, convergence is rather slow. You also have these square dots. The square dots are people asked for this price, but they didn't get. When you post the price, you don't know what's there on the other side. So you can post a price which is excessively high and nobody will buy. So see, this is because you don't. When you fail to sell, you don't know whether it's because somebody else. And if there was excess supply and somebody else made the sale, or whether it was because your price is too high above the demand. So learning takes place quite slowly, but it does take place. By the 10th period, you are nearly at equilibrium in the competitive equilibrium. Now at the 11th period, the supply is low, but the prices adjust very slowly relative to oral double auction. You have prices declining. Now it's very strange. If you look at those white squares, the white square means that the offer is, the posted price is there, but it was not sold. Now this is a situation where you have excess supply. So I guess that makes sense. There are 6 extra units. So you can see that the basic thing we learned about the difference between posted price and oral double auction is that posted prices are much more rigid, much more inflexible. And so basically, if you want to think about Keynesian economics, then the posted price is the right paradigm. Oral double auction doesn't really represent the normal world markets where you don't have both sides bidding. The sellers normally post their price and they stick to them. When you go to a store, you don't negotiate with the storekeeper about. Actually, in the olden times, this used to happen much more, but nowadays fixed prices are much more common. So the question is, why are there such big differences between posted prices and ODA? And also there is some asymmetry. You see, when the prices were high, the posted prices discovered the competitive equilibrium, but when they were low, they did not. So there is rapid convergence towards competitive equilibrium if it is high, but when it's low, there is not. So there is asymmetry. So why? So we need to understand these things. So first of all, oral double auction allows for quick discovery of excess supply or demand. You have people bidding from both sides, so a lot of information is being revealed, and you can see that the sellers are not able to sell. A lot of people are offering for sale, but they are not getting any buyers. So you can see that there is excess supply, and vice versa. When there is excess demand, you can see. And actually, if you have some market situation like this, you can easily discover whether there is excess supply and demand. In posted prices, this is not so easy to discover whether you are in excess supply or excess demand. In fact, when there is excess supply, then all of the sellers, in this 11-16, the 11 people who sell don't discover whether there is excess supply. Only the 5 people who don't make the sale, they discover that there might be excess supply. They are not even sure because the prices were posted, and so it might be that there is no excess supply. It's just that they posted too high a price. See, in oral double auction, they would be able to adjust, and then they would see that regardless of what price, no one is buying. So that means that there is no more demand. Everybody has. So then they would be. But in posted prices, you don't even discover about excess supply. So information is much less, and you know that the standard supply and demand assumptions are full information, zero transaction cost. And as we have seen many times, these are just ridiculous assumptions. They don't make any sense. They don't correspond to reality, and they make a big difference. That's the thing. That's the most important thing, that the people say that maybe there's not full information. There will be 95% or 90% or eventually. So it doesn't make much difference. But this is not true. When you have zero information, when you have low information and high transaction costs, then things are very different. Like we have seen in this experiment, the adjustment does not take place. So when you are going up, then a seller calls out a price and he makes a sale. So he says, I see, I can make a sale. So when making upward adjustment is rapid. In the other direction, what you understand is that you need to price below what the other people are asking. If you don't make a sale, so people don't go to the limit price, but they follow each other, and this process could be quite slow. As long as any one person doesn't make a sale, other people make a sale, so they repeat their same prices, but the other person who didn't make a sale, he says, I shouldn't be the top price. So he goes to the second price. He wants to maximize profits, obviously, so he doesn't want to be the highest price, so he goes to the second price. So that means that the adjustment process will be quite slow, and now the new top price says, oh, I'm not making a sale, so he goes again to the second price. So the adjustment downward is not as rapid as the adjustment upwards. So there is low communication information. Now, one very important concept which runs throughout this chapter, which you need to understand, is the strategic behavior of the buyers. Now, you see, the sellers post prices. What can the buyers do to try to prevent them from posting high prices? Basically, the only way to try to influence what is happening is what's called withholding purchases. So there is a standard natural buyer strategy. You have a market, every seller has a posted price, so you should go to the lowest price available and try to buy, and maybe you want to buy 5 units, and so the cheapest price has only 1 unit, so you buy from him, and then you go to the second cheapest, and then you buy however much is necessary from him, and so on. So this is called the standard, the natural buyer strategy, where you're not being strategic. Now, if you want to be strategic, then you might say that, okay, I can buy at this price, but I don't want to give the signal that there is demand available at this price. I want them to lower their prices. So even though you can buy in the sense that your value is higher and you have the money available, you just say, okay, I won't buy, just so as to cause prices to decline. So that's called strategic withholding of demand. So now in the experiments throughout this chapter 4, they use two types of, they use human buyers, and then they study whether there is strategic withholding or not, and what effect does it have on the sellers. And the other strategy is, okay, let's assume that the sellers just behave naturally. So if the sellers just behave naturally, don't use strategy, then you can actually just put a computer to do the buyer behavior, because buyer behavior is automatic. It doesn't have any thought involved. So that is called simulated buyers. So in many experiments, you have simulated buyers. They follow the standard rule. You buy as much as possible at the cheapest possible price, and then you go to the next. So in this situation, so this is, if you're going to read this chapter carefully, then you will note that in some experiments they have simulated buyers, in some experiments you have this strategic human buyers, and they use strategic withholding to try to influence prices. Alright, so we have covered the first possibility, which was the case where you have box type design and you have either excess supply or excess demand. Now this is the second case that we want to study, to see the difference between the ODA and the PP market. And so now in the second design, you have multiple equilibria. You have 3 sellers and 3 buyers. All the sellers have cost $5. All the buyers have cost $6.10. Now, if you look at this, there are 3 trading periods. In the first trading period, each of the buyers has 2 units and each of the sellers also has 2 units. So there are 6 total units. You see that the prices, the posted prices are very low. They are very close to the cost, and then they rise. Basically, the first seller or one of the sellers posts low. The second seller posts near competitive equilibrium, or not competitive. There is no competitive. Actually, all of the prices are competitive equilibrium, but the middle point is the point at which there is equal surplus. Both of people get the same. Third seller posts above, Then in the second period, the prices rise. The third period, prices rise. And in the fourth period, all the prices are above the equilibrium, and two prices are even above the cost, so there are only 4 sales. That was session 1. There are actually 3 different sessions. Achha, those are the average prices in session 1. If you look at the PO1, the 10 trading periods within the session, you see that there is a rise in the posted prices up until they converge to the top. In PO2, which is the session 2, there is a rise to the top and then there is a decline, and in 3 there is the prices stay more or less above the equality. So in all 3 sessions anyway, it seems that the prices are above the equal surplus point. So it seems that when you post prices, then the posting gives you an advantage, and basically that's the result that you can see from the experiment, that when you post prices, this gives you an advantage because you cannot negotiate. So when you refuse to negotiate, then you can extract more surplus. And anybody who has a mother knows this, because if you go into the market, your mother can always get a better deal than you can. So that means that if you allow for, and the only weapon that the seller has, I'm sorry madam, our prices are fixed, we do not negotiate. So when you do that, then even your mother cannot do anything. So the posted price system is advantageous for the seller, and that's what these results are showing. But if you just think about it, it's not obvious. It's just from the experiment, from experience that we know this. It is not by any logic. And this is the thing, that the game theory does not tell us the answers that we are looking for. If you just try to calculate theoretical maximization, this maximization, this, you cannot get the understanding. The experiments show that this is what happens, and our real life experience shows that this is the truth. But otherwise, if you just apply logic, you can come up with any kind of reasoning to come up with any kind of solution. Okay, here is the same experiment with oral double auction, and you have basically you have B1, B2, B3 and B4. There are 4 different experiments. In B2 you have prices which are roughly stable at the midpoint between equal surplus and maximum for the sellers. But in B1 the prices decline so that there is no surplus. In B2 prices are at the midpoint, in B3, and in B4 they are. So what's happening here? Well, what's happening in ODA is that the buyer and the sellers are completely symmetric. There is nobody has any advantage. So it depends on how skillful people are at negotiating. So whichever party has stronger negotiators, they will prevail. Now there is some equilibration, that is, if a price is set, then everybody follows that price. That's what we see. I mean, it's not that trading is taking place all over the map. Some sort of equilibrium emerges. Basically, it's a tradition. Okay, in this market, this is the price that's dominating. But this price can be very high, it can be near midpoint, it can be very low. This is different from the posted prices where the sellers always are at an advantage. So again, this is theory which is very different from anything that you read in textbooks from theory, because theory does not predict advantage to sellers.
Sir, अगर sellers के कोई homogeneous product है और seller different prices कर देते हैं post, उसमें भी तो जो lower price होगी पहले तो उसकी तरफ सारे seller जाएंगे ना, क्योंकि सर जो हमने experiment किया था ना, हमारा ये experiment था, उसमें एक seller ऐसा था कि जो कि betray कर रहा था, बाकी seller को आपस में इनके कलूड कर रहे थे कि हमें एक प्राइस रखनी है.
सही.
ये capacity
So people
constraint
will go capacity constraints as long as that seller with the smallest price is limited by capacity, then that will be exhausted, and then the other sellers will be able to make the sale. So different types of results can emerge.
है. सर जो बिट्रे कर रहा था ना स्टार्टिंग में ना वो बिल्कुल कम्पिटिटिव प्राइस पे उसका था, लेकिन इसके बाद जो ना मोनोपोली केस.
Yeah, when he sees that you can make more profits, then you will raise your price.
सारी सेल हो जाती थी, सारी क्वांटिटी सेल हो जाती थी, उसके बाद जो बाकी सेलर्स होते थे वो एकदम से प्राइसेस.
सही है. So he would say that, well, why not? I can also.
लेकिन
Exactly.
लॉन्ग रन जो बिट्रे कर रहा था उसका सरप्लस कम था.
We will discuss your experiments later, inshallah. Alright. So the third condition that we wanted to look at is the shifting demand. So if you look at the top figure, and again we have seen this already result, you have a case where the demand continuously keeps rising for the first 10 periods, and then it continuously keeps declining for the next, it's 8 periods and 8 periods in this experiment. So if you look at the oral double auction, then basically the prices follow the shift, so that as the demand keeps increasing, the prices keep increasing to move towards the competitive equilibrium. And that makes a lot of sense because you have a lot of revelation of both demand and supply in oral demand. And then when the demand decreases, then again the prices track the decrease and they keep going down. But if you look at the posted offer markets, things are very, very different. Now, as the demand increases, the posted prices are not able to keep track of this demand increase. See, the dashed line is the equilibrium, the competitive equilibrium. The competitive equilibrium is increasing very fast, but the final contract price, which is the square dots, the stars, they don't follow it. They go up, but only very slowly. The average price is the square dot and the final price is the star. So the average price doesn't go up; it goes up slowly as the equilibrium price, and it just basically it catches up on the downside, and then it does seem to detect that demand is going down, but again very slowly. So basically the tracking is very slow, so you can say that there is a lot of price rigidity. So basically the result from this kind of experimentation is that the posted price does not respond well to shifts in demand, but it does respond well, and that's not shown here, to shifts in supply for obvious reasons. When you change the supply, the suppliers will adjust their posted prices. So when the supply is shifting, then the posted prices can handle that, but it cannot handle shifts in demand very well. All right, so the second factor that we want to study in this chapter 4 of Davis and Holt is what are the things which cause high prices. High prices means prices above competitive equilibrium. So basically this chapter studies monopoly, duopoly, oligopoly and market power in these in using experiments to see. So here is a simple experiment with monopoly. You have 5 buyers and 1 seller. You have a demand and supply situation. The monopoly price is calculated and it is 110. It's the vertical dashed line, and the you can see in the first period the price starts at sort of midpoint between competitive equilibrium and monopoly price, and then in second period it jumps exactly to the monopoly price. In third period the seller asks for more than the monopoly price. In fourth he asks for less, but from the fifth period onward it converges exactly to the monopoly price. So basically the seller finds, and he doesn't know the demand, so he has to search for what is the maximization price, and eventually he finds it and then he sticks to it. So this time the theory of monopoly works to give you the solution, the equilibrium. Now a large number of experiments have been conducted. So there is a monopoly effectiveness index which basically tells how much of the surplus you extract. So depending on different kinds of conditions, people can extract all of the monopoly profits or some of it. So there are two types of conditions. First of all, you see this is a list of a large number of different experiments on monopoly. So the first condition is subject experience. So X is experienced, dx is design experience but not particular experiment experience, and nx is no experience. And the buyers can be human, in which case, especially against monopoly, the buyers may refuse to buy when they can do so, to try to make the monopolist lower the price. And the monopolist, if he doesn't discover how much demand there is, he will, what he's trying to do is to estimate what is the maximum profit he may make. Suppose that the monopolist charges the maximum price and there are 5 buyers, and we say, all right, we don't want him to let him make monopoly. If we can collude, we can say nobody buys. Okay, so nobody buys in the first period. He says, okay, profits are 0 at this price, so let's reduce the price. So let's suppose we don't buy until he reduces the price close to competitive. So when he reduces the price close to competitive, then everybody buys. Then from his experience, that is the profit maximizing solution. So as long as if the buyers collude, they can, so by strategic withholding of demand, they can get the monopolist to reduce the prices. So now the question is, if the buyers are separated, will they be able to do this? Will it be to their benefit? So basically the monopoly value M, that depends, that reveals how much of the monopoly profit the monopolist could make. So now that's one factor, whether there is, so the human buyers will be able to do strategic behavior, the simulated buyers will not, because they are programmed to just buy at the lowest price. So that's one of the conditions. The third condition is the cost function. Now you see, if you have decreasing costs, then the monopolist wants to sell as much as he can, because the greater the volume, the more his profits, because the costs are low. So when you have decreasing costs, then the monopolist's incentive is to expand production, but the monopolist makes profits by not expanding production, because that's how, by restricting the supply, that's how he gets monopoly power. So decreasing costs is sort of antithetic to monopoly power. Increasing costs, on the other hand, makes it natural for the monopolist to try to reduce the volume of sale, and so the results, however, go in the opposite direction. Increasing costs hurt monopoly power, you can see there is one experiment or two experiments with increasing costs, and the monopoly effectiveness is low, 45% in the first and 9% in the second, and decreasing costs or constant costs make monopoly effectiveness large. So basically simulated buyers helps monopoly, increasing costs hurt monopoly power, and experienced buyers also make a difference. There is a discussion of all of this and the reasons for this in the textbook. Now there is some discussion of how the monopolist finds the maximizing price. So in typical experiments, like this is a simple experiment where you have a straightforward straightforward demand and a straightforward supply function. So as the monopolist increases price from $0 to $1, his all of the buyers have value above $1, so everyone buys. So your revenue is just 3 times your price. So the profits increase from $0 to $3. Now when you go from $1 to $1.01, then your one of the buyers drops out of the market. So now from $1.01, your profits are $2.02 because there are only 2 buyers at this price. So now it is possible that if you are making small changes, you might say, oh, I have discovered the profit maximum and it is $1. But if you increase the price to 2 cents, again there is no $1.02, then your profits becomes $2.04. So that zigzag line is actually your profits. So as you keep increasing prices and you get to $2, then your profits become $4, which is much more than $3 that you are making at the $1 price. So it's not so easy to discover. For a large range of prices above $1, you are still not making as much as you were at $1. But eventually you do catch up. So at $2 you are making a lot of profits. Then when you increase above, then again it starts zigzagging, and so the maximum profits is at $2. But it's not so easy to discover. So the maximization problem is not an easy one to solve in experimental situations. And so it's not necessarily true that the monopolist will be able to discover the profit maximizing price. So basically the theory says that yes, sometimes the monopolist can find the monopoly price and maximize, but there are many situations in experiments where the monopolist will not be able to take full advantage of his monopoly position. And this corresponds to the real world also. And this does not correspond to the textbook theory, which doesn't take into account any of these complications. So now we go to the second situation where the prices can be higher than the competitive equilibrium, and that's where the oligopoly situation is. So basically in oligopoly there is the possibility that all of the firms compete with each other just like a competitive market, and if that happens then you can get fairly close to competitive outcome. And this is what your textbooks tell you, that okay, even if you have oligopoly you can apply supply and demand theory to it. Supply and demand theory only applies in competitive markets. So basically they say that you can neglect oligopolies, and it is true that you can if they compete with each other. But when you run experiments, then you find that collusion is possible and it can occur, especially if you allow people time to learn the game. So in fact, in some of the examples they ran the experiment for 100 periods, and so they found that somebody who running only 20 periods or 50 periods even would not discover that oligopoly is possible, but in the long run oligopoly can emerge. So experiments show that collusion is possible. There are two types of collusion. There is implicit collusion. Nobody talks to each other, but you can watch what the other people are pricing, or you can learn how the other people are pricing, even if there are both kinds of experiments where you can see what the other people are doing, or you cannot. But even when you cannot see, from your own demand you can detect what the other people are doing. So conclusion is possible. You can get implicit collusion. You can, if you allow for it, you can get explicit collusion. So a lot of things depends on the communications. How much people can talk to each other. What is the message space? What is the kind of message that you can convey to the others? So now a lot of different experiments have been conducted, and it turns out that everything matters, in the sense that if you change one factor, then the results change, and there are many different factors: message space, possibility for collusion, what the buyers are doing, whether they are allowed to communicate, whether they can behave strategically. So all of the things that we think can matter do actually matter, and experiments show that. So the situation is therefore far more complex than you find in your textbooks, but it is not so complex that you cannot understand it. You can understand all of the different factors and how they act separately, and then you can try to understand. The final factor is that there is market power. Now the market power, the way that this text has defined it, and it's also the way that it's defined in law, is that one seller can act unilaterally. He doesn't depend on other people, and if he can raise prices and make profits even though everybody else is behaving competitively, then he has market power. So a monopolist always has market power by definition, because he is the only seller. So as we've already discussed, the market monopolist may not be able to exploit this market power if there are human buyers, and if they use strategy to deceive him about the nature of the demand. Sometimes they can even punish him for greedy behavior. So he knows that there is demand, but people say, no, we refuse to buy unless you use fair pricing. And this actually happens in the real world as well. So that is one possibility which will prevent monopolists from exploiting market power. The other is lack of experience, which means that the monopolist will not be able to discover the monopolist price. He will not be able to discover the demand and so on. So he may not be able to find the. And the third situation where the experiments show that the monopolist is unable to find the maximum, the profit maximum, is the case where you have increasing costs. Okay, in duopoly we have two sellers, and in this experiment we have both sellers have market power. There are two prices. There is the competitive price, where both parties behave competitively, and then there is the price with P, which is the market power price. So if you look at the posted offer situation, then the sellers can collude with each other, and they can raise the prices to the level which is the one which is sort of the monopolistic price in all 4 sessions. When you have oral double auction, then the prices stay between the market power price and the competitive equilibrium. So the double auction is more advantageous for the buyers and less advantageous for the sellers. And so these are 4 sessions with basically the same design and the same amount of market power in a duopoly. And in the double auction situation, the sellers are not able to exploit as much of their market power as they can in the posted offer situation. There are 2 sessions, 2 types of sessions. The bold lines are the ones with experienced participants, and the thin lines are the ones without experience, but both of them give similar results. Here is another experiment. This is the one that actually we have discussed earlier. There is a no power design and there is a market power design, and then the design is switched from one to the other. So these are the results for the posted prices. So if you look at the top situation has no power for the first 30 periods, and the posted prices decline very slowly towards the competitive equilibrium. In the next 30 period, you give one of the sellers market power, and then you see that the prices jump up to the higher price, the textbook calculates the mixing distribution for S1 and S2. This is the randomized Nash equilibrium, but this randomized Nash equilibrium doesn't really say anything about how actually people behave and doesn't really predict what happens. It's not really relevant to the actual situation. In the bottom design, you have market power in the first 30 periods and no power in the remaining 30. So in the market power, again you have high prices. When you switch to competitive equilibrium, when you switch to no power, then the prices do decline in the posted price offer, but they don't go all the way to competitive equilibrium. They stay comfortably above competitive equilibrium. So all right, now we come to a second topic in industrial organization. So the first topic was what are the effects of different types of market structure if you have 2 big firms and lots of small firms, capacity constraints, information, rules about collusion. So basically everything has an effect. That is what we have learned, and they have the natural types effect most of the time, and so the experiments can reveal these effects, and the game theory does not reveal the effects. The game theory leads to the wrong types of ideas about what will happen. So now we come back to the monopoly and we ask, okay, monopolies are going to exploit the consumer. So what can we do to regulate the monopoly? So there is this theory which is called the Loeb-Magat regulation. What happens here is that you see this is your standard diagram. The demand line is the vertical one, and then you have the marginal revenue, which is sort of the steeper line, and you have average cost and marginal cost. So now, since the marginal cost is below the average cost curve, at the competitive equilibrium, where the marginal cost equals the demand, the firm will actually make losses. So initially the firm will start out at the point where the marginal revenue curve intersects the average cost curve. That's the QM, the first line, the dashed vertical line. So now how can we get the monopoly to produce more and sell it at a lower price? So basically the Loeb-Magat regulation mechanism says that we pay the firm the additional consumer surplus. So when it produces more, it gets a subsidy. So when that changes its cost structure, and you can show that if you pay the full surplus, then the profit maximization amount for the monopoly will now be at the competitive equilibrium, where the marginal cost is intersecting the demand. Now the problem with the Loeb-Magat is that the amount of subsidy that you need to pay the monopoly is very large. So there is a proposal that, well, we can also tax the monopoly to get rid of excess profits. Another way is that we can ask for different contractors to bid on acquiring monopoly rights. So the amount of surplus that they would expect to make in this situation, they would then, in a competitive auction, they would be bidding. So the subsidy that they need to be provided would be available from the revenue generated by selling the monopoly rights. So that's one mechanism. But there is another mechanism which is called the Finsinger-Vogelsang. And what the Finsinger-Vogelsang does is that instead of paying the full monopoly, as you expand, any loss of revenue that results, that is compensated. So it's a little square box as opposed to the full consumer surplus. So the monopoly is encouraged to expand, and if they suffer any loss in revenue, which is what would happen, then they get a subsidy. So that leads to much smaller subsidies, and also it leads to less knowledge. I mean, to get the Loeb-Magat subsidy, you have to know exactly the full demand curve, whereas in the Finsinger-Vogelsang, you don't need the full demand curve because you can calculate. We were making this much before, and now we are making this much. So what happens in experiments? Well, in these different experiments, the Loeb-Magat regulation creates better than competitive outcomes. You have negative monopoly power, and so people overexpand production because they get lots of subsidies. So these are three experiments where if you have monopoly power, then you have 56%, 72% and 78% of the monopoly value. Then in Loeb-Magat regulation, in the last two experiments, these two succeed in expanding volume and reducing prices, and so monopoly power disappears. The second type of regulation is a contested market where you allow other people to enter, and so there is the source of restraint on a monopoly is the threat of entry. So how well that works? Well, in this particular case, it seems that the contested market also reduces market power in these experiments, because the value of the monopoly power is 0.2, 0.9 and 0.6, which is much less than the monopoly power. So as I already discussed, there are huge subsidies which are required by Loeb-Magath mechanism. So two solutions have been proposed in the literature. One is to require monopolists to bid for the rights to monopoly. The other is to use alternative Finsinger-Vogelsang. There are some problems with the original Vogelsang mechanism, but they have been corrected. I won't go into the technical details. Now, the second way that the industrial organization literature says, it says that you should not regulate monopolies, because you don't need to regulate. As long as there is potential entry, that's by itself, and even monopoly will not exploit monopoly power, because if they try to do so, then some people will enter, and when they enter, then the monopoly profits will be lost. So to prevent entry, they will keep the prices low, and so according to some theory, they will actually be at competitive price levels, because any price at which they are making profits, entry can occur, and so that is one theory. So the experiments show that there is some power, but it is not quite like what the theory says. So this is a decreasing cost duopolist. There are two people in the market. I am now not sure whether they are I think it's just they can enter or exit at will. So that's why this is a flow market. I mean, it's in continuous time. So you see that if you look at the top bold-face bars, you have price near competitive equilibrium, then the price jumps to the monopoly, then it jumps back down to competition. It keeps going up and down like this, and in period 20 it jumps up above the monopoly price, and then it slowly declines to the monopoly price from period 20 onwards. If you look at the posted prices, for periods 10 to 15, this is just a magnification of the chart in the top line. So you see that the prices start out high and then they decline. When you see, you are seeing in period 11 that I think one of the people drops out of the market, then they re-enter. So the threat of entry does cause some control, but doesn't cause full control. So there is no situation is quite complex. It's not as simple as the theory says, that if you have threat of entry, the monopoly will charge competitive prices. So as we have seen in duopoly also, that if there is theoretical Bertrand price competition with full information and zero cost, then you do get to competitive equilibrium with just two sellers. But if you drop full information, zero transaction costs, then you can get to monopolistic outcomes. So here we are also seeing something similar, that the threat of entry can cause prices to decline, but doesn't have to, and the prices keep fluctuating between the monopolist price and the competitive price. So, summarizing the results about contestability, there's a lot of different experiments here. So basically, like all of our experiments show, that the results depend on the microstructure, exactly how you structure the experiment. So market efficiency is a measure of how close you are to competitive equilibrium. So if you look at the first line, it has experienced buyers and sellers. RX means role experience. That means that there were people who had experienced buyers in other games, but not this particular game. So the efficiency under monopoly that was predicted was 60% of competitive equilibrium, but when they ran the experiment, they observed 49%, much stronger monopoly power than predicted by theory. But when they changed it to a contested market where somebody else could enter potentially, the efficiency or competitiveness increased to 86%. And similar results were observed in another experiment where the contested market increased the efficiency. Similarly, in Milner, Pratt and Riley, the predicted efficiency under monopoly was low, and that observed under monopoly was also low, but when the contested market, it increased. So certainly the theory of contested market has some valid points. It is true that the threat of entry acts as a restraint on monopolist power. The final topic in this chapter 4 of your textbook is about predatory pricing. The standard and classic case of predatory pricing is that you set your prices low to drive out your opponent, and then you raise the prices. So we used to have a local ice cream brand that was making asli doodh, and in Lahore they had a good ice cream, and then there was this multinational that came in and set the prices very low and drove them out of business, and then they took over their factories, and now the same brand is marketed with the same name, but it is now owned by the multinational. So that's example of predatory pricing. Now the economists, as a rule, if you read the textbook, say predatory pricing doesn't exist. Why? Because it doesn't make any sense according to theory. It says that, okay, if you set prices low, you will make losses. Actually, any predatory pricing means that you are setting prices so low that you are actually going to make loss. But you do that to drive the opponent out. So they say, okay, you make a loss and you drive the opponent out, but when you raise the prices, then again entry will occur, and so there is no benefit. But this doesn't happen like that, because there is no zero transaction costs, and there's lots of frictions. So one of the theoretical angles is that if you do predatory pricing, basically you have a huge amount of funds. So if you're a big multinational, then you can take a lot of losses for a while, and you can enter the market, and you can also do learning. So now once you are high up on the learning curve, entry cannot occur, because in order to gain that experience, people need a lot of time, and they don't have as deep pockets in order to put in the losses required to catch up. But this is the type of thing that you cannot assess in labs, because the learning part is not available. But cost structure is very well under control in labs, so you can detect whether or not there is predatory pricing. So there are a number of experiments that can be done. So initial experiments confirmed the economist's bias, and there is a paper called In Search of Predatory Pricing, in which he finds that there is no predatory pricing. He set up the experiment to allow for the possibility that one of the firms could drive out the others by using low costs, and he was given enough deep pockets that it was possible for him to do so, but that didn't happen. So some people have made proposals to prevent predatory pricing, and one of these is that if you have entry, then what you should do is prevent the incumbent firm, the one that is already in the market, from expanding quantities, so that they can't drive the new entrant out of the market by expanding sales. And the other proposal is that you should prevent them from making temporary price cuts. They can make a price cut, and then they have to hold it for 5 periods. So that's now actually people tested these rules, and they found that they create a lot of inefficiency. So the standard, then orthodox economist position is that predatory pricing doesn't take place. If you try to make rules to prevent it, that will cause a lot of harm. However, there's another experiment, Harrison's experiment, in which there was predatory pricing. See, basically the initial experiments were that both people there was only one market, and you could either enter or not enter. If you don't enter, you have no chance of making any profits. You're out of the game. So basically everybody always enters. So then the being driven out is rather difficult. So Harrison did something clever, which was, he said that there are 5 markets. In 4 of the markets there is one large seller already present, and then there is a 5th market which is in which there is no large seller. And now everyone has a chance, I think there are 5 sellers or maybe more, to enter any one of the markets. So now so there are 5 different markets. So now the incumbent can either try to prevent entry by keeping the prices low, or he can actually move out of that market. And similarly, the person can try to threaten entry, or he can enter some other market. So this created the possibility, and in this Harrison's experiment, he did observe some amount of predatory pricing. But the experiment had some unusual features, and that meant that it was difficult to replicate. So this chapter studied 3 issues. One was the oligopolistic structure of markets, and whether this results in above competitive high prices, and they found yes, it does. So now then the topic was how to regulate such markets. So there is decentralized regulation, which basically Loeb-Magat or Finsinger-Vogelsang mechanisms. These work. And then there is the idea of contestable markets, which is also a way of preventing high prices. If you allow people, you make it easy for people to enter and exit, and that also has effect. And then if you allow contestable markets, then you can have this phenomena that the oligopolist or the monopolist may prevent this contestation by forcing people out of the market, and that might cause the contestable markets theory to collapse. So basically these are the conclusions for these from the textbook. This is just a copy of the concluding section. So we don't have any definitive answers to any of these questions, in the sense that in different conditions different kind of things happen. So one of the what are the findings? Well, contestability does appear to control monopoly in discrete time single good environment. But if we look at posted offer situations and we look at environments where you can have hit and run entry, which means easy entry, easy cost, there's no fixed cost to entry, and if you exit you can quickly exit without forsaking a lot of loss. So in that situation you do have contestability, but efficiency also erodes. So the standard theory of contestability, which you read in standard industrial organization text, is falls apart in this. It doesn't work like what the textbooks say. It does work, but it works in very different ways. Decentralized mechanisms show some promise. Predation does not happen too often in simple markets, but if there are multiple markets, then predation can happen. So these are the results. And so that for the industrial organization. Now the chapter summary. Chapter is basically about posted prices. That posted prices have reduced interactions. There is less revelation of demand. Typically, even if you have ideal conditions, you have very slow convergence to competitive equilibrium, and the convergence occurs from above. If you look at the whole process, then there is huge amounts of surplus for the sellers and much less for the buyers. So again, as I have said in many different places, that the standard textbook theory is the capitalistic theory of markets. It basically favors the capitalists and it hides all their advantages. So the competitive equilibrium theory says that there is no excess profits that the firms can make, but the firms are making billions of dollars of excess profits. Why? Because there can be entry. In the long run it will be wiped out, and all of these things don't happen. And similarly, the oral double auction theory says that the surplus that is in the market will be shared equally between the buyers and the sellers, but the posted price mechanism shows that the capitalists will make most of the surplus and the buyers will not. And so if you look at the industrial organization theory, which as addressed by experiments, then we find that monopolies usually have above competitive prices, but may not reach full monopoly price for many different reasons. Duopolies can either collude explicitly, or they can collude tacitly, or they can fail to collude depending on the microstructure. Threats of entry can have impact, but the theory of contestable markets as studied by experiments is very different from the game theory, which leads to different and wrong conclusions. And it is possible to regulate monopolies. Again, this is one of the Chicago School ideology problems, that they don't like regulation even of monopolies. They say because they say that the costs of regulation are even worse, and the cure is worse than the disease. So at least in experiments this is not true. In experiments you can regulate monopolists and get to better results with higher efficiency. Alright, so that is the end of this lecture, and now I'm going to shut this off and I'm going to ask about